section 8.2, connecting position, velocity, and acceleration using integrals. Whitney is going on a bike ride. This graph represents her velocity at any time. The vertical axis is in miles per minute. The horizontal axis is in minutes. The first question, what was Whitney's acceleration at t equals 9? So we're looking at this point right here. The derivative of velocity is equal to the acceleration. The derivative, we're talking about the slope. So we want to know what is the slope of this curve. And the good news about this one is we have a definite point right there. We have another definite point right there. I could also use the point at the bottom. Any of those green points that I have, we have some what are called lattice points. We can figure out exactly the coordinates. So we have 8, comma 0.6. We also have 14, comma negative 0.6. So if you calculate the slope between those, that is going to be your acceleration. So I can take, let's see, 0.6 minus negative 0.6 divided by 8 minus 14. Negative 0.2 miles per minute squared. Number 2, explain what is happening from t equals 11 to t equals 16. So from t equals 11 to t equals 16, we have that. What's going on? Well, for that entire region, the velocity is negative. So in that situation, Whitney has changed direction. In the context of the problem, instead of going toward her friend Ann's house, she's headed home. Why might that be happening? Maybe because she forgot something at home, or she just wanted to get something from home. And it looks like she didn't make it all the way there because the area under the curve from 0 to 11 is much bigger than from 11 to 16. So maybe she dropped something along the way and she found it, but she didn't make it all the way home because the displacement doesn't go back down to 0. She didn't make it all the way back to her starting point. Question number 3, what does that integral represent? So from 0 to 24, that represents her displacement. It would be her change in position. And to calculate that, we need to calculate the area of all of these regions. So the area of the yellow region, which is a trapezoid, would be so the two heights, base 1 is going to be base 2 is going to be 11 divided by 2 times the height of 0.8. So that's going to give us the height of the first region. No, 3. It's going to be a 3. Our base is 3. Plus the triangle. This triangle is going to be negative. So 1/2 times our base from 11 to 16. That base is 5. The height is negative 0.6. And then we have one more triangle, 1/2 times our base, which is 8, times our height, which is 0.6. And if we sum all those together, we get 6.5 miles. And again, this is her displacement or change in position. So from where she started to where she ended, she is 6.5 miles different, closer to her friend Ann's house. Hopefully she made it there. Question number 4 has the absolute value of v of t integrated. So what does that represent in the problem? This would be the distance traveled. So it's going to take all of those areas, but it's going to take the region that was negative, and we're going to make that positive. So we're going to take all these values the same. The only difference is instead of the negative 0.6, we're going to make it a positive 0.6. This area was 1.5 miles. So instead of subtracting 1.5, we're going to add 1.5, which is going to make this value come out to 9.5 miles. So that was the total distance traveled by her because, again, she went backwards for a little bit. At t equals 12, is Whitney speeding up or slowing down? So at t equals 12, I see her velocity is negative because this is a velocity graph. The slope right there is also negative, so her acceleration is negative. And since her velocity and acceleration have the same sign, that means she is speeding up. She's speeding up in the negative direction. And we know that because V of t and A of t have the same sign. They could both be positive, they could both be negative, but they have the same sign. That's how we know she is speeding up. Number 6, what does this represent in this problem? So the inside, we already did this integral. That was a displacement. The displacement divided by 24 would represent her average velocity. Average velocity. And so then if you actually calculate that, it was 6.5 miles divided by 24 minutes. And if you actually divided those, you get 0.271 miles per minute. So it represents her average velocity. Do you think this is an accurate measure of how strenuously Whitney was pedaling? I would say no, because we had that stretch where she had a negative velocity that worked against her. And so it looks like she's not going very fast. If you wanted to get an idea of how much she's actually working, a better thing to calculate would be her average speed. To take the 1 over 24 integral from 0 to 24 of the absolute value of V of t dt, the total distance traveled, the 9.5 miles, divided by the 24 minutes. And I think that would be more accurate to how much she was actually working on this. So that negative velocity ended up not helping her because it didn't actually show how far she traveled.